There is something living at the bottom of the ocean, not something we put there, not something we understand, something that evolved in complete darkness, under pressure that would crush steel, in cold that hovers just above freezing, in a place where the sun has never, not once in the entire history of Earth, sent a single photon of light. Something that belongs to a world so alien that when we pull specimens up to study them, they arrive destroyed, dissolved, distorted, shattered by the simple act of entering ours. We have been to the moon. We have landed robots on Mars. We have sent a probe beyond the edge of our solar system. And yet this, right here in our own ocean, remains in almost every meaningful way unknown. I want to ask you something before we go any further, something I think about a lot. You are sitting right now on a planet that is covered, 71% covered by ocean. That ocean has an average depth of 3.7 kilometers. Its deepest point is 10,935 meters, and the total area of ocean floor that has been directly mapped in high resolution, actually seen, actually measured, is less than 25%, less than a quarter of our own planet's floor. We have better maps of the surface of Mars. We have better maps of the moon. We have better maps of Venus, a planet shrouded in clouds of sulfuric acid, than we do of the bottom of the ocean we sail across every single day. That means right now, at this moment, there are creatures living in the dark water beneath our ships and our beaches and our fishing nets, creatures we have never seen, never cataloged, never named, going about their lives in a world we cannot safely enter. They were there before we arrived on this planet. They will be there long after we are gone, and we have barely looked. Today, we are going to look. We are going to descend slowly, carefully, layer by layer into the deepest place on Earth, the Mariana Trench, a scar in the floor of the Pacific Ocean so vast, so extreme, so extraordinary that it should be the most famous geographical feature on our planet, and yet most people could not point to it on a map. By the time this video ends, I promise you two things. The first is that you will understand this place, its scale, its geology, its biology, better than you did before. The second is that you will be left with more questions than answers, because that is the honest truth about the Mariana Trench. The more you learn about it, the more you realize how much remains in. Picture the year 1875. The British naval vessel HMS Challenger, a converted warship 69 meters long, smelling of wet rope and coal smoke, sits alone in the middle of the Pacific Ocean. There is no land visible in any direction. The nearest coastline is more than 2,000 kilometers away. The crew has been at sea for 3 years, mapping the ocean floor in a way no one had ever attempted before. Their method is simple and physically brutal. They lower a lead weight on a long rope until it hits bottom, then pull the whole thing back up by hand. Meters of cold, salt-soaked heavy rope, over and over, hundreds of times in every kind of weather. The picture that has emerged from those hundreds of soundings is consistent and, frankly, boring. The ocean floor seems to be a flat, featureless plain of gray mud and silt, sitting at around 3 to 4 kilometers depth almost everywhere they have tested. It is the same, always the same. On this particular day, in this patch of Pacific, they lower the weight again. It feeds out through their hands. 3 kilometers, 4. The rope keeps going. 5 kilometers. Men start exchanging glances. They tie on more rope. 6 kilometers, 7. The ship has gone quiet now, except for the creak of the hull and the slap of water against the bow. 8 kilometers of rope, the weight of it alone almost more than they can manage, and still the lead has not touched anything solid. It is important to understand what the ocean meant to people in 1875. Sailors still told stories, passed down through generations, treated not as myth but as genuine warning of creatures that rose from the deep, things with eyes the size of cartwheels and tentacles that could embrace an entire ship and drag it under in minutes. These men standing on the deck of the Challenger were not immune to those stories. They had grown up with them, and right now, beneath their feet, through a thin wooden hull into black water they could not see, a rope was going down and down and down into whatever was waiting below. It finally hit bottom at over 8 kilometers. The men stood in silence, doing the mental arithmetic that told them they were floating above a hole so deep it defied comprehension. They recorded it in the ship's log. They noted the coordinates. They pulled the rope back up and they sailed on. They had, without fully realizing it, just discovered one of the greatest geographical features on the surface of our planet. The place would be named after them, the Challenger Deep, and if they had moved their ship just slightly to the west, they would have found its deepest point, a location so far below sea level that if you could somehow pick up Mount Everest and lower it in, the summit would disappear beneath the surface and continue sinking downward for another 2 kilometers before it was anywhere near the bottom. The Mariana Trench stretches for 2,550 kilometers, longer than the entire width of the continental United States, curving in a great arc through the western Pacific, beginning south of Japan and sweeping westward toward the Philippines. At its widest, it spans nearly 70 kilometers. The Challenger Deep alone could swallow 5 Grand Canyons. For the crew of HMS Challenger, the discovery was a footnote in a larger expedition. For science, it was the beginning of a question that we are still, 150 years later, nowhere close to fully answering. To understand why, we need to go much further back than 1875. We need to go back 170 million years to when the ocean floor that feeds into this trench was first formed. Because the Mariana Trench is not a geographical accident. It is the result of forces that have been shaping and reshaping this planet since long before life even walked on its surface. And those forces, still active, still grinding, still violent, are what make this place not just deep, but genuinely unlike. The surface of our planet is not one solid piece. It is broken, cracked like the shell of an egg into roughly 15 major tectonic plates. These plates float on a layer of semi-molten rock called the mantle, and they are dragged across the globe by enormous convection currents churning through that rock below them. In some places, plates pull apart. In others, they collide. Both processes reshape everything on the surface above them. Every mountain range, every ocean basin, every trench. The Atlantic Ocean is getting wider right now. The Americas are drifting westward, away from Europe and Africa at roughly the speed your fingernails grow. Over millions of years, that speed has opened an entire ocean. And as the Americas move west, they must be getting closer to Asia, which means the Pacific Ocean, on the other side of the Americas, is getting smaller. The floor of the Pacific is moving westward on a geological conveyor belt, and when it reaches the western edge of the Pacific, something extraordinary happens. The Pacific Plate, the piece of ocean floor flowing toward the Mariana Trench, was created 170 million years ago. This ancient slab has spent its entire existence traveling slowly westward across the floor of the Pacific. And now, at the western edge, it meets the younger, lighter Philippines plate, and it loses. It is forced downward, bent by unimaginable force, driven back into the molten rock from which it formed. The oldest ocean crust on Earth being destroyed. This process is called subduction. It is responsible for 90% of all earthquakes. It creates the ring of fire, the chain of hundreds of active volcanoes that encircle the Pacific. And where the descending plate bends downward, it creates the trench, a wound in the ocean floor kilometers deep, stretching for thousands of kilometers. But the geology of the Mariana Trench goes beyond the ordinary violence of subduction. This is a place where the destruction of rock produces phenomena that exist nowhere else on the surface of the Earth. On the flanks of the trench, enormous mud volcanoes erupt, one of them 50 kilometers in diameter, pouring hydrogen and serpentinite mud into the Pacific water. On the trench floor, a different type of volcano erupts liquid carbon dioxide, not gas. The pressure at that depth is so extreme that carbon dioxide cannot exist as a gas. It comes out of the Earth as a liquid, pooling in the volcanic crater like mercury in a bowl. Another vent has a crater filled with molten sulphur, a phenomenon found in only one other place in the known solar system, Io, a moon of Jupiter. And then there are the hydrothermal vents, columns of superheated, mineral-rich water exhaling from fissures in the trench walls, supporting entire ecosystems powered not by sunlight, but by chemistry. These vents are believed by many scientists to hold clues to the very origin of life on Earth, environments where complex chemistry can occur in the complete absence of sunlight, driven by geothermal energy alone. Some of the organisms that live around these vents, bacteria that thrive in temperatures above 100 degrees Celsius, are considered the closest living relatives of the earliest life forms on Earth. Life may have begun somewhere very much like this, more than 3.5 billion years ago. We are talking about a place that produces phenomena found nowhere else on Earth. A place so geologically extreme that our standard frameworks for understanding geology barely apply. And it sits right here, in our ocean, and we have barely looked at it. But geology, extraordinary as it is not the main story today. The main story is what lives here, and to understand that, we need to descend, layer by layer, through the water column.
The surface of the Pacific in the Mariana Trench region looks like any other tropical ocean. Blue, calm, warm. If you were floating here, looking down, you would see nothing unusual. The water is clear, but the dark starts quickly. Nothing on the surface tells you that 11 kilometers below your feet, one of the most extraordinary environments on Earth is quietly going about its business. Let us go down and find it. 0 to 200 meters, the sunlit zone. Here, the ocean is full of life, and all of it is powered by a single process, photosynthesis. The phytoplankton in this layer, organisms so small that thousands fit comfortably on the full stop at the end of this sentence, convert sunlight and carbon dioxide into organic matter and oxygen. They produce roughly 50% of all the oxygen in Earth's atmosphere. Every other breath you take right now came from here. Not from a forest, not from a field, from invisible organisms floating in the top 200 meters of the world's oceans. The food chain starts here. Phytoplankton eaten by zooplankton, zooplankton eaten by small fish and jellyfish and krill, those eaten by larger fish, and so on, upward through tuna, swordfish, whale sharks, blue whales, the entire immense architecture of ocean life built on this thin, sunlit foundation. And downward, everything that dies here eventually sinks, carrying the energy of the sun into the dark below, feeding an ecosystem the sun never reaches. At 200 meters, the light begins to fail. This is the twilight zone, a region of dim and dying blue light where photosynthesis is no longer possible. Despite the near darkness, an astonishing amount of life exists here. The fish biomass in the twilight zone may be 10 to 20 times larger than all previous estimates suggested. We simply did not know it was there because we had not looked properly. The most numerous vertebrate on Earth lives here, not a creature most people have ever heard of. The bristle-mouthed fish, a small, unremarkable-looking animal barely 8 centimeters long, with spiny, outward-pointing teeth and a faint bioluminescent glow along its belly. There may be quadrillions of them, more individual bristle-mouthed fish than there are grains of sand on all the world's beaches combined.
the most successful backbone animal in the history of our planet, thriving in a part of the ocean we barely study, and most people have never heard its name. Every night, creatures in the twilight zone migrate upward, toward the surface, toward the food. Every morning, they retreat back down into the dark. This daily vertical migration is the largest animal migration on Earth, happening every single day, invisible to us above the surface. Billions of tons of biomass moving in coordinated waves through hundreds of meters of ocean twice a day, every day, transporting carbon from the sunlit surface into the deep, a process critical to regulating our climate, and we understand only the broadest outlines of how it works. At 1,000 meters, the last trace of sunlight disappears. We enter the midnight zone, where it is permanently, absolutely, completely dark. No sun has ever lit this water. No photon from the surface has penetrated this far. The temperature is a steady 4 degrees Celsius. The pressure is 100 atmospheres, 100 times what you feel right now. And it extends downward for another 3,000 meters before we even reach the upper edges of the deepest zone of all. The pressure here would kill you in a fraction of a second. Not by drowning, there is not time for that. Your lungs would compress to roughly the size of a fist. The air pockets in your sinuses and middle ear would collapse. You would not die slowly, you would simply cease to be structurally intact in milliseconds. At 1,000 meters, 1/10 of the way to the bottom of the Mariana Trench. And yet, life. Extraordinary, baffling, magnificent life. Organisms that have spent millions of years solving every problem this environment poses, not fighting the pressure, accommodating it, not generating warmth, conserving energy so efficiently that warmth becomes unnecessary, not seeking light, generating it. Bioluminescence, cold chemical light produced by living organisms, reaches its most elaborate expression here. More than 76% of deep-sea animals produce their own light, blue-green mostly, because blue-green travels farthest through water. They use it to find mates in the dark, to confuse predators, to lure prey. The midnight zone, which should be featureless black, is, if you could see it with the right eyes, a shifting, pulsing, silent light show of extraordinary complexity. At 6,000 meters, we enter the Hadal Zone, named for Hades, the Greek underworld, the realm of the dead. It is not an unreasonable name for a place where the pressure is 600 times the surface, where no sunlight has ever arrived, where food is extraordinarily scarce, and where the very chemistry of life must function differently to survive. The walls of the Mariana Trench close around us now, sheer cliffs of dark rock falling away on either side. The sediment on the floor below us is fine and white, accumulated over millions of years from the slow rain of organic particles descending from the surface above. Some of those particles took 50 years to fall from the surface to where we are now. By the time they arrive, they have been partially consumed by organisms on the way down. What reaches the floor is degraded, transformed, almost unrecognizable as food. And yet, organisms live on it, evolved for it, depend entirely on it. The bottom is coming, and what is waiting there will challenge almost everything you thought you knew about what life required. The floor of the Challenger Deep, approximately 10,935 meters below the surface of the Pacific Ocean. The pressure here is 1,099 times what you experience right now. The temperature is just above 2 degrees Celsius. It is absolutely dark. The sediment beneath us is white, ancient, undisturbed except by the slow passage of the creatures that call this place home. Let us meet them. The Hadal snailfish, Pseudoleparus swiri, the deepest vertebrate ever recorded, found at depths exceeding 8,300 meters. It does not look like a deep-sea monster. It looks fragile, translucent, pale, almost colorless, like a small, flat fish that forgot to finish developing. Its body is soft and slightly gelatinous. It has no scales, Its bones are thin and flexible, and that is precisely the point. Where shallow water fish have rigid bodies that resist pressure, the Hadal snailfish accommodates it. Its cell membranes contain a compound called trimethylamine oxide, TMAO, that stabilizes proteins and enzymes at pressures that would unfold and destroy them otherwise. The higher the pressure, the more TMAO the fish produces. It is a pressure management system built into the fish's biochemistry over millions of years of evolution. The snailfish does not fight the deep. It was built for it. In 2023, a Japanese research team captured footage of a Hadal snailfish at 8,336 meters, a new depth record for a vertebrate. It moved easily, it fed, it appeared entirely at home. Then there are the Hadal amphipods, small crustaceans, relatives of the sandhoppers you find at the beach, adapted to the crushing pressures of the deepest ocean. They are scavengers primarily, drawn in swarms to any organic matter that falls to the trench floor. When researchers lower baited traps into the Challenger deep, they retrieve them swarming with amphipods, hundreds, sometimes thousands. In a place where food is almost impossibly scarce, these animals have evolved to find it with extraordinary speed and efficiency, and to consume it entirely. Amphipods in the Hadal zone have been found with plastic, microplastic fibers and particles in their digestive systems. At the deepest point on Earth, an ecosystem evolved over millions of years is already ingesting human industrial waste. Sea cucumbers, relatives of starfish and sea urchins, make up more than 90% of all large animal life on parts of the trench floor. They move slowly across the sediment, ingesting it, extracting what fragments of organic matter remain, passing the rest through. They are, in the truest sense, the janitors of the abyss, recycling the last scraps of food that have fallen from the sunlit world 11 kilometers above, making those nutrients available to the microbes and other organisms that share the floor. Some Hadal sea cucumbers have evolved to swim, briefly, clumsily, but genuinely to swim, lifting off the sediment and drifting short distances through body movements that should not produce any lift at all. In creatures that have no eyes, no brain beyond a simple nerve ring, and no apparent reason to go anywhere, this adaptation remains unexplained. Now the anglerfish, perhaps the most famous deep-sea creature and one of the most remarkable predators that has ever evolved on this planet. In the absolute dark of the midnight zone, the female anglerfish carries a spine rising from her forehead with a small glowing lure at its tip. Light produced by bioluminescent bacteria living inside it, bacteria in a symbiotic relationship with their host, fed by the fish, doing their job in return. In total darkness, that small light is the most dangerous thing in the water. Anything drawn to it will find itself inside a mouth lined with transparent, inward curved teeth, teeth designed so that once anything enters, it cannot leave. The anglerfish does not chase, it does not need to. In the dark, the light does all the work. Female anglerfish can be 30 times larger than males. Males, once they find a female, bite into her skin and begin to fuse, their circulatory systems merging, the male's body slowly atrophying until he is little more than a pair of reproductive glands attached to her side, fed by her blood. Biologists discovering this for the first time initially thought the small attached lumps were parasites. They were not parasites, they were husbands. Then there is the giant squid, Architeuthis ducks, the largest eyes of any animal on Earth, each eye up to 27 centimeters across, the size of a large dinner plate, evolved for a single purpose, to detect the faint bioluminescent glow of sperm whales hunting in the dark water above. An arms race in the midnight zone, conducted in complete silence and near total darkness between two of the largest animals in the ocean. The largest giant squid ever recovered and measured was 13 meters from mantle to the tip of its longest tentacle. There is no reason to believe this is the maximum size they reach. Sperm whale stomach contents and skin scarring from squid suckers, suckers ringed with sharp chitin teeth, suggest encounters with animals significantly larger than any specimen ever collected. We have never filmed a living giant squid in its natural habitat in the deep ocean at full size. What the giant squid does in the dark, at depth, for most of its life, we genuinely do not know. And then there is the bear eye fish. A transparent head, a completely transparent skull filled with clear fluid through which the fish's bright green tubular eyes, pointing straight upward like telescopes, are clearly visible from the outside. The bear eye hunts from below its prey, its extraordinary eyes tuned to detect the faint silhouettes of small animals against the dim light filtering down from above. When prey is spotted, the eyes rotate forward for close-up targeting. For decades, scientists who studied these fish in nets thought the two small spots on the front of the head were its eyes. The actual eyes, invisible inside the transparent dome, were only discovered when researchers observed living specimens in their natural environment for the first time in 2004. We had the fish, we had studied it, and we were looking at entirely the wrong thing. This is not unusual in deep-sea biology. We often think we understand a creature based on preserved or damaged specimens, and then when we finally observe it alive, we discover we were looking at something completely different. The deep ocean has a way of making us realize how much we assumed and how often those assumptions were wrong. In 2014, during dives near the Mariana Trench, researchers observed large gelatinous structures floating above the trench floor, transparent, slow-moving, clearly biological, and matching no known species in any database. They were filmed, no specimen was collected, no DNA was taken. What they were, whether an unknown life stage of a known species or something entirely new to science, remains to this day unanswered. They were there, they were filmed, and they still do not have a name. The question this raises is one I think about every time I read a new deep-sea paper. If these are the things we have found in the fraction of the deep we have actually looked at, what is living in the parts we have not?
Here is a number I want you to sit with. Approximately 12 people have walked on the surface of the moon, and for the first 52 years after the first crewed descent to the Challenger Deep in 1960, not one additional human being made the same dive. 0. The most extreme environment on our own planet, in our own ocean, was visited once and then essentially abandoned, while we went to the moon 6 times and launched probes beyond the edge of the solar system. That first dive was made by 2 men in a vessel that had no business surviving the attempt. Don Walsh of the United States Navy and Swiss oceanographer Jacques Piccard climbed into the Trieste, a steel sphere 2.1 meters across, suspended beneath a buoyancy tank filled with aviation gasoline. No thrusters, no ability to maneuver. They would simply sink and hope the sphere held. They took nearly 5 hours to reach the bottom. At 9 kilometers, still 2 kilometers from the floor, there was an enormous bang, a structural sound. In a pressure vessel at that depth, that kind of sound means something has failed. Walsh and Piccard looked at each other. The vessel appeared intact. They kept going. What they did not know yet was that one of the thick plexiglass window blocks in the outer access tunnel had cracked. A non-load-bearing component, but one whose failure is an early warning of progressive structural compromise. They were 2 kilometers from the bottom of the deepest place on Earth. They descended anyway. They reached the floor. They peered through 2 circular windows 50 millimeters across. The sediment they had disturbed on landing swirled in their lights, obscuring almost everything. For 20 minutes after a 5-hour descent, they looked into the dark, and they saw movement. Something pale, something alive, moving across the floor of a place where science had said nothing could survive. It was enough. The question was answered. Life was here. They began the 3-hour ascent. Nobody would repeat the dive for another 52 years. In 2012, James Cameron descended alone in a purpose-built submersible called the Deep Sea Challenger, spending 3 hours on the floor.
He described the experience as lonely, vast, featureless, and profoundly alien. Since 2019, a surge of private ocean exploration has dramatically changed the pace. Victor Vescovo's 5 Deeps expedition made multiple dives to the Challenger Deep, reaching a measured depth of 10,928 meters, the deepest human dive ever recorded. His team discovered 4 new species of crustacean on the floor. They also found a plastic bag and sweet wrappers. The total number of humans to have reached the bottom of the Challenger Deep now slightly exceeds the number who have walked on the moon. We are, in the most literal sense, just getting started. In June 2023, the submersible Titan imploded during a descent to view the wreck of the Titanic at 3,800 meters, less than a third of the depth of the Challenger Deep. All 5 people aboard were killed instantly. Among them was Hamish Harding, who in 2021 had made the longest and deepest crewed dive to the bottom of the Challenger Deep in history. A man who had been to the deepest point on Earth and returned safely, killed by the ocean at a fraction of that depth in a different vessel on a different mission. The deep ocean does not reward complacency. It does not become safe because you have been lucky before. Every dive is a negotiation with physics, and physics does not make.
Here is what we know about the Mariana Trench. It is the deepest place on the surface of our planet. It was created by the subduction of the oldest ocean crust on Earth. Its geology produces phenomena found nowhere else. Liquid carbon dioxide volcanoes, molten sulphur craters, mud volcanoes the size of cities. Its floor supports life, microbial life in extraordinary density, and larger animals that have evolved specifically for this environment and nowhere else. We have explored a tiny fraction of it. We have found dozens of new species in that fraction. We have also found microplastics and plastic bags, evidence that we are already changing a place we have barely begun to understand. Now here is what we do not know. We do not know how many species live in the Hadal Zone. We do not know how they interact, what the food web of the deep trench actually looks like in any real detail. We do not know how the microbial communities in the trench sediment function at the molecular level, or what role they play in global ocean chemistry. We do not know what the giant squid does for most of its life. We do not know the upper size limit of deep-sea species we have collected only in fragments. We do not know what lives in the more than 90% of the Mariana Trench floor that has never been sampled. We genuinely, honestly, do not know. I find this one of the most exciting facts about our planet. Not frustrating, exciting. Because we are living in the moment just before we find out. The technology is coming. Autonomous vehicles that can withstand hadal pressures and operate for weeks are already in development. Soft robotics that can collect specimens without destroying them are getting better every year. Environmental DNA sampling can now identify species without ever catching a single individual, just from the traces left in water that is passed. We are building the tools to ask the questions properly, and the answers, when they come, are going to be extraordinary. Consider what we have already found. A fish adapted at the cellular level to pressures that destroy ordinary biochemistry. Crustaceans that swarm in the millions at the deepest point on Earth, living on food that takes 50 years to reach them. Structures filmed in the Hadal water column that no scientist alive can currently identify. An entire twilight zone biomass, 10 to 20 times larger than we thought, conducting the largest daily migration on Earth, twice a day, every day, completely unobserved from the surface. Every single time we have looked properly at the deep ocean, we have found something that rewrites what we thought was possible. The Mariana Trench is the last great secret on Earth, not in some abstract poetic sense, literally. There is more unknown biology at the bottom of our own ocean than in any other environment on this planet. We are not running out of things to discover. We are at the very beginning of discovering them. And I think that matters beyond science. We live in a moment where it can feel like everything has already been found, everything cataloged, everything mapped.
The sense of genuine mystery, the feeling that there are things out there truly beyond our current knowledge, waiting to be understood, has become hard to find. The Mariana Trench gives that back to us. It just requires us to look down instead of up. In the time you've been watching this video, more marine snow has drifted down through 11 kilometers of ocean and settled silently on the floor of the Challenger Deep. The Hadal snailfish has moved through its dark world with no awareness that we exist. The amphipods are swarming something that fell from above. Whatever those unidentified gelatinous structures are, they are still there, doing whatever it is they do in complete and absolute darkness at the bottom of everything, entirely unbothered by our ignorance of them. The mystery of the Mariana Trench is not a problem waiting to be solved. It is a story waiting to be told. And we are still in the very first pages. The next discovery is already down there. Something living in the dark, something with no name yet, waiting for us to finally look. This is Daily Explained. Stay curious.